Hi students, welcome to this video segment. My name is Samuel Chubu Emeka. In this video session, we shall discuss continuous compound interest. Please, before you begin this video, it is highly recommended that you view the video on simple interest, on compound interest, and also the prerequisite videos on those videos. It is important you view them. It is also important that you view my video on log reading. I did a video on log reading. It's also important that you view that video. Especially in this video session, we shall apply some laws of log reading in order to get some questions, in order to get some answers to some questions. Okay, so let's get started. Assume you invest $1. Okay, let's say you invest $1 in a bank that has an annual interest rate of 100%. Although I'm yet to see such banks, because I don't know. That's really, if I see such a bank, I will go immediately. Now, assume you invest $1 in a bank that has an annual interest rate of 100%, right? Compounded several times. We shall consider the times, okay, per year. Then, after 1 year, what will you have? So let's say the several times we talk about is compounded annually, compounded semi-annually, compounded quarterly, compounded monthly, compounded daily. So let's see how much you will have, so that we kind of, from there we can now see, observe something. Ordinarily if they ask you, okay, if you invest some money in a bank that compounds annually, and you invest in another bank that compounds semi-annually, assuming they have the same interest rate, of course you expect the one that compounds semi-annually, because semi-annually means it compounds 2 times in a year. So you expect to have more interest in that bank, okay? And also, if you invest in a bank that compounds quarterly, that's 4 times in a year, you expect to have a higher interest than the one that compounds semi-annually 2 times. So, but let's see. Now, is there any limit? Now business mathematicians now said, okay, is there gonna be any limit? I mean, if you compound even daily, right? Then you compound hourly, then you compound per seconds. Is there any limit that you can get? I mean, because when you're dealing with money, is there any limit that you can get? So, assuming you compound it continuously, that is per hour or per minute or per second, will you have more money? Is the difference going to be much? Like if you look at the difference between compounding daily and also compounding monthly, what is the difference? Is there any limit that we can get that you can't get above that limit? So this is an open question. Let's see what we shall get. Okay. So now let's now make a table. Now recall, the compound interest formula. A will be P 1 plus I, and this was the first formula I gave you. in that video. And I also gave you another formula. A will be P 1 plus R over M MT. Okay, we've defined all this. Okay, so look at your look at the videos. Now we shall use this and see what we can get. Okay, I've got to erase because this will be takes note of M. M is number of compounding times per year, number of compounding periods per year. Okay, let's now see what we can get. Okay, please, I want space here, so I probably will erase this. You can pause the video to write it down. So let's start with the compound interest formula, and that is A will be the one we will use is P1 parenthesis 1 plus R over M, then MT. Okay. Now, from what we mentioned, from the question, the first question we asked, we see that P is $1. We invested $1, right? Then R is 100%. 100% is 100 over 100, which is 1. 100% means 100 over 100. Percent means all over something out of 100. So R is 1, and then T is after 1 year, right? T is 1 after 1 year. So this is what we have to follow by. Then we now make a table. Okay, we make a table, and if compounded, then we have our M. How many times? How many number of compounding periods per year? And then we have our A. What will be the amount after that? So let's see whether, if we compound it, let's see the amounts and see whether we can have a limit to how much you can make. Okay. All right. Now, to how much somebody can make when the person deposits to the bank that compounds continuously. Okay. Now, if compounded annually, that means that annually means that how many times do you compound in a year? 1 at the end of the year, 1 time. Then A will be what now? Let's solve for A. A will be B is 1, 1 plus 1 over 1, then 1 times 1. So A will be 1, 1 plus 1, then 1, which is A will be 1 times 2 raised to the power 1, right? A will be $2. So this will be $2. All right. Now we've compounded semi-annually. Semi-annually. That means semi-annually means how many times do you compound in a year? 2 times. So what would this be? A will be 1 plus R is 1 over M is 2, then 2 times 1. So this is 1 plus 0.5 raised to power 2, right? Which is 1.5 raised to power 2. You see, I'm doing it PEMDAS, order of operations. So 1.5 to the second power gives us what? 2.25. So this is 2.25. Okay? So you see, just a difference of 25 cents. A bank that compounds annually compared to a bank that compounds semi-annually. All you get is a difference of 25 cents extra. Okay? Now let's do quarterly. What if you compound quarterly? Quarterly means you compound 4 times in a year. So what would the amount be? It should be bigger than this. So let's see how much it will be. So A will be $1, then 1 plus R is 1 over M is 4, then 4 times 1. Okay? So that will give you 1 plus 1.25, right? 1 plus 0.25 raised to the power 4, which is 1.25 raised to the power 4. Okay? So when you do that, what is that? 1.25 raised to the power 4. Now, I showed you how to use this the other time, and also I came with my laptop today so that I can show you also how to solve some questions here with the calculator on your laptop. So how much? This will be $2.44. You see? 2.44140625. Okay, what if we compound monthly? Monthly means that M is 12. So what will it be? It will be A will be 1 plus 1 over 12. 12 times 1. So A will be 1 divided by 12 is a lot, right? So we just do it like we'll do it. Don't round up, don't round now. You round at the final answer. I always say this on my video. Please do not round in the middle. Round at the end. Okay? It is very important. Otherwise you won't get the answer. Well, okay, this is 0.0888333333. Then plus 1. Yeah. Because the more number of decimals you round, the more accurate, the more precise it is. Okay, precision. Okay, this is 1.083333 raised to power 12. And that is 2.61. Approximately 2.61. Okay. You see, this is just a difference of sense, some sense. What if we run daily? Daily. And this is the how many times? 365. 365. Then that would be A equal to M equal to P1. Then 1 plus arrow is 1 over 365, then raised to power 365 times 1, right? So what will it be? 1 divided by 365, then raised to power 365. Okay, 1 divided by 365 plus 1 raised to power 365. 2.71 is about 2.71. Okay, 2.714567 and the rest of them. Now, if you keep raising this guy, let's raise this guy to like 500. Assuming we do it to 500, right? It will be 1 divided by 500 plus 1, then raised to power 500. It will be 2.72. You see, 2.715. Now, for the purpose of this, we have this as 2.714567. Here we have 2.715569. If we do 1,000, right? It will be 1 divided by 1,000. If we compound it 1,000 times, okay, if we compound it 1,000 times in a year, compounding continuously, then this will be 1 divided by 1,000 is this, then plus 1, then raised to power 1,000. It will be 2.716924. Now, as you keep doing it, if you compound it 10,000, assuming you compound it 10,000, it will be 1 divided by 10,000, then plus 1, then raised to power 10,000. Okay, 1 divided by 10,000, then plus 1, then raised to power 10,000. 2.718. If you compound it 10,000 times, I hope you don't get confused from what I'm writing now. It will be 2.718149. If you compound it 100,000, right? If you compound it 100,000 times, what do you get? 1 divided by 100,000. Okay, then plus 1. Do this yourself, okay? Then raised to power 100,000. It will give you 2.718268. So it will be a constant letter. It will constant. If you do 1 million, you still get 2.718 something. So that means that there is a limit to how much you can get, no matter how many times it is compounded. Now, if you do 1 million, it's going to give you 2.718 something. I bet you. We can do it. We can, assuming we do 1 million, you'll see if we do 1 million, which is 6 zeros, 1, 2, 3, 4, 5, 6. So that will be 1 divided by 1 million, then plus 1, then raised to power 1 million. It will give you 2.7182805. Okay, so you see 2.718, 2.718, 2.718. It comes up to constant. So there's a limit to how much you can get, no matter how many times the principal is compounded in a year. Now, this we pay, well, will I say tribute? Okay. The man that discovered this constant here, as you keep increasing the number of periods, the number of times you can compound it in a year, the amount keeps going to a constant. And that constant is what we call Euler constant. Euler constant. Now, this is a mathematician that is well known in the mathematics. A scientist as well. I think he's a French scientist, I think. Euler. And he also has something Euler-Benula equation. Okay? So it's mathematics and science. Yeah. So this is what we call Euler constant. And that is what you see as E in your calculator. You look at your calculator, you see E. E is that what we call Euler constant. That is E. So if you do E raised to power 1, which is E, is approximately that 2.718. Approximately. So if you have your computer on or your calculator, I'm going to show it to you with my calculator, and I'm going to show it to you here. Okay, so I'm going to show it to you here with my calculator. The E, in this calculator, it is E raised to power X. I don't know whether you see it. I mean, it's E raised to power X, which is this. Is on top of ln. In is the ln. Well, not really in. Some people say ln. Yeah. The ln, and then on top of it is the E raised to power X. So that means if I want to get E raised to power 1, I've got, because it's on top, I have to press the shift key. So what I will do is I will press shift first, I'll press E raised to power X, and I'll press 1 and execute. That's 2. If you see it is 2.718. Look at what I did again. I pressed shift, then I pressed E raised to power X, and then I pressed 1. Now, some calculators you probably will need to press 1 before you press E raised to power X. It depends on the calculator you're using. I mean, this one is because this one I'm using, it requires you to press the function first before you press the constant. Some calculators, you need to press the constant first before you press the function. So just know the calculator, the way it gives you. Now I will show you how to get it on the computer, with the calculator on the computer. Now, the logarithm to the base E. Now, the logarithm to the base E the logarithm of a number, let's say x to the base e, okay, which is also written as ln x. Okay, this is what we call the natural logarithm. Natural logarithm. Natural logarithm. But probably you didn't do this in school. Probably the one you did is just the normal log. We have the standard log or the normal log, and then the natural log. The natural log is to the base of e, where e is the Euler constant. Euler is a scientist, French scientist, I think. So now, when you take the inverse of that e, it gives you the ln. Okay, that's why if you take the inverse of e, I mean, okay, if you take the inverse of e, it gives you the ln. Okay, now look at what I mean here. If you do ln of e raised to power 5, okay, or you can do log to base e of e raised to power 5. So this means 5 log e base e, and that is 5 times 1, which is now 5. Okay, yeah. So the ln is just like an inverse of it, or you can say it either way. That's why you see e raised to power x on top and then ln below. Now sometimes you might see ln on top and then e raised to power x below. Okay, so whichever one is just an inverse of each other. Now, if you have your calculator, this is a Windows PC that I'm using. It might be different from Mac, I don't know, but this is the calculator from Windows PC. Now, when you go to the calculator as usual, you get to view and you get scientific. Now, if you look at this scientific right now, it doesn't have e raised to power x. It doesn't have that, okay? But it does have ln. It does have ln. Now, and it does have INV. INV means inverse. So, how do you get the e raised to power x? Since you don't see it here, what you have to do is to click on inverse. If you click on inverse, it gives you that the inverse of ln is e raised to power x. Okay, inverse, and you press 1 first. You see, in the calculator here, you have to press 1, and then you press E, and it gives you that. You see that now? In the calculator, you have to press the function first before you press the E. So if you want to go back to the E, you have to press inverse, e raised to power x. If you press inverse again, gives you ln, gives you the ln. So if you're using your calculator, you probably won't see e raised to power x. Just press the inverse function and it gives you e raised to power x. And then if you press inverse again, it gives you ln. Okay, now that is the case. So let's go and find this formula here. We now see that as recall your compound interest formula. Okay. Haven't you wondered the simple interest formula, the amount, for finding the amount was used in deriving the compound interest formula. And then the compound interest formula is used to derive the continuous compound interest formula. So let's derive this, please. This is 1 plus R over M MT. Okay. Now, as of course your P is a dollar and R is 1 and the T is 1. Now we observed that as M tends to infinity, we saw, we got that P is equal to $1, R is 1, and T is 1 here. Okay? Now we saw that as M tends to infinity, then this tends to, this here, this tends to, as M tends to infinity, then this tends to 1 plus R over M MT tends to 2.718. Okay? Now, but we can rewrite this as, we can rewrite the formula, we can write the formula as A equal to P 1 plus R over M, then R over M over R times RT. Now, did you see what I wrote now? Because I want to derive a formula, okay? So we can write this as M over R times RT. Of course, this thing is still the same thing as MT because R will cancel R, right? So in this case, we see that our M over R, M is M over R times RT. So we consider it that this here will tend to E. Because actually your T is 1. Remember, actually your T is 1. Okay? And the R is 1. So the main guy here is just the M. So it doesn't help. Okay? M divided by 1 is still M. So the main guy here is still the 1. Okay? All we just did was times RT because we wanted to prove this formula. And this tended to E. This tends to E, which is 2.718. So this now, if you look at it, the main guy here is even M anyway. So this still tends to E, right? And this will now be that A will be PE raised to power RT. And this is what we call your continuous compound interest formula. Okay, that's it. So this is the formula we'll use to finish these questions, and then we can call it a day. All right. Now let's go to calculations. Okay, let's start solving calculations. All right. So, simple interest formula for finding the amount. That's finding the amount in a simple interest formula calculation is used to find the compound interest formula. And the compound interest formula is used to find a continuous compound interest formula. Okay? All right, let's get started in solving questions. Number 1, we know that A is equal to PERT. And they say we should find A, right? So A will now be, the principal is 3,000, then R is 5.0. Now, what is the R now? Because we have, like I told you, if you want to use R to solve, that's, if you want to use R in solving to get something, then you have to put it as a decimal, you have to divide it. But if you're looking for R, then later on you multiply it to get the percent. Okay, R is 5.05%, which is 5.05 over 100. Which is 0.0505. Okay, and our T is 2 years. Excuse me. Yeah. Excuse me. So our T is 2 years. All right. So this will be E 0.0505 times 2. Okay. So A will now be 3,000. Now look at the way you just do this, okay? So we don't waste time here on the calculator. You first of all, well, you do like B PEMDAS. Remember B PEMDAS. Then please excuse my dear Aunt Sally. Now, do the exponent first before you multiply. This means 3,000 times E. Now this E also, you have to multiply first. So, go to our calculator. We do 0.0505 times 2. So it gave us 0.101. So you now do A will be 3,000 times, you now do E of this, okay? So you do shift E of the answer, shift answer. And that is 1.1062766642. And then you multiply, then you now do times 3,000. And that gives you $3,318.83. Okay, this is waste of time. Honestly, it's waste. Well, it's not waste of time, but I'm sorry, it's not waste of time. But you keep writing this. Will you keep writing the whole this thing, even if it's 20 digits? No. So I'll teach you how to do it with my calculator and then the calculator on the computer. So look at what you do first. You go ahead and you do 0.0505 times 2. So it gave us this 0.101. And our EX is here. So that means I have to press the shift function in order for me to use it. So I press shift, I press E. Now, instead of me to type this again, 0.101, if I want, I can do it. But instead of me to do it, I will just say, because my answer is also here, that means I have to press shift to get the answer. The answer I just got. I press shift again, I got the answer here. And then I press execute. He gave me that. Then he gave me this, E of the answer. And then I now multiplied times. And I do times 3,000, and execute, and he gave me this. Okay, but if you don't know how to do E of the answer, just write E of 0.101. Yeah, but sometimes this might be long. You can use this, okay? If you're not being timed, you can use it. At least this will make you get the correct answer. But I wouldn't use it. I mean, I would just do it immediately and get my answer. Now, unless your instructor says you must show all your work, you know, if your instructor says you must show all work, then you have to do it that way. Now, just make sure you follow the order of operations. That's important. If I want to do this on the calculator on the computer, so what I will do is I'll first of all do 0.05 times 2, and that equal to 0.101. Then I have to do inverse to get my E, and then I'll do E raised to power that immediately. I press the E immediately. It gives me that right away, right? Then I'll do times 3,000 equal to, and it gives me the answer. Yeah. So that's the way you do it here on the calculator on your computer. Okay. And round up as needed, 2 decimal places. Okay. Now, let's do the second problem. Number 2, find P if A is this, okay? So let's make P the subject of the formula. Let's make P the subject of the formula. Let's express P in terms of A, R, and T, okay? We make P the subject of the formula, or we express P in terms of A, R, and T. Okay, or we isolate P, right? Okay, A is equal to PERT. So we rearrange PERT is equal to A. Then we divide both sides by this. So P will be A over ERT. Okay, so let's now complete this. A will be what? 7,700 all over E. R is what? 9.71%. That gives you 0.0971. Okay? So this is 0.0971 times T is 8 years. 8. Okay, so what did we get as our P? Now in this case, you can use your memory on the calculator. Use the memory on the calculator, but first on the calculator on your computer. But let me first of all do this with this, okay? See what I do first. I'll come and do, remember PEMDAS, 0.0, let me put this, 0.0971 times 8, execute, gives me 0.7768. Then I'll do shift, then E, shift of the answer. That gives me 2.17450. This. Then this the answer I have now, right? So I will do 7700 divided by shift of the answer. Shift of my answer. And that gives me 3541.04. Okay? So I have 3541.04. Okay, so if you are doing it step by step, you have to multiply this, then you have to find the E of this, you write it out, and then you now do 700 divided by whatever answer you get. If you're doing it step by step. Okay, what if you want to use the calculator on the computer to do this? So we're going to use the memory. I talked about using the memory in the compound interest video. So first of all, we do 0.009 0.0, no, I messed up. Let me go back. 0.0971 times 8. Okay, equal to this. Then I'll press inverse, and I'll press E to give me that. Give me 2 point this. So I will store it on memory. So I will say memory M plus. I'll store it on memory. Then I'll now do 7700 divided by recall memory recall MR. Okay, and I'll press this. So 7700 divided by, I press MR, memory recall, and I press that, and it gave me the answer. Okay, so just play with it. The next one, question 3. So what does this tell you actually? It tells you that if you invest $3,541.04 in a bank that pays 9.71% annual interest rate, then if it's compounded continuously, after 8 years you will have $7,700. So from 3,000 something to 7,000 something. So that's what it tells you. I mean, if it's compounded continuously. That's the interpretation. Okay. Number 3. You know what? I've finished 1 and 2. So remember, this says assume continuous compounding of interest. Assume continuous compounding interest. Now, they must tell you what formula to use if they are asking the question. Yeah. Or they'll mention continuous compounding, okay, of interest, or continuous compound interest formula. Okay. Find R if P is equal to 7,000, A is this, and T is this. Round to the nearest integer as needed. Okay. Let's solve it. Okay, let's solve for R. A is equal to PERT. So PERT is equal to A. We divide both sides by P. This means P times. Okay, so divide both sides by P. Divide both sides by P. Divide both sides by P. We have that E raised to power RT will be A over P. Because P divided by P here will be gone. Okay. View my videos on literal equations. It's important. So now, we've got to release this guy. He is holding it, right? So here we just have to take the natural logarithm, okay, of both sides. Take the natural logarithm of both sides. That's the ln of both sides, okay? Take the natural logarithm of both sides. So we now see that ln, that natural logarithm is the ln I told you about, ln ERT. Or it could be log, it can also be written as log 2 base E ERT. Let me, you know what, let me just write it. But look, your ln ERT is the same thing as log 2 base E, because your ln, natural logarithm, is the log to the Euler constant as the base. Log 2 base E, ERT. From laws of logarithm, this is RT log E base E. And this is RT times 1. And that gives you RT. Now, the law of logarithm, log A base A is 1. Log 1 base 1 is 1. Log 2 base 2. Log B base B is 1. Log 2 base 2 is 1. Log Samdom for peace, base Samdom for peace is 1. Log Samdom to base Samdom is 1. So log E to base E is 1. That's how you get it. So when we take the natural logarithm of both sides, this will now be ln A over P. So this gives you RT automatically. Okay? Will now be ln A divided by P. So your R, you're asked to find your R. So you divide both sides now by T. Divide both sides by T. So your R will now be what? This means that your R will be ln A over P divided by what? T. That is what it is. That is it. Okay? So let's get it done. Let's do it. And then I can erase this. Let's now do the problem. You know, whatever you're asked to find, is better you first of all make it the subject of the formula first. So our R will now be ln A is what? 14,381.03 divided by R at P is 7,000. Okay? Then all over T is 9 years. So let's find the R. So this will be ln, if you're doing it step by step. But I'll show you how to do it right away. I'll show you how to do it right away. 14,381.03 divided by 7,000. So you have 2.054432857 all over 9. And all you need to do is to just take ln of the answer. Lean shift answer, which is a 0.71999879 all over 9. An arrow will be divided by 9, which is a 0.07999. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 8088. Now multiply it by 100. 1, 2. It will be 7.9999. So approximately 8%. Okay, R is 8% because they say you should approximate it to the nearest integer. 8%. Okay, let me show you the way I did it here. So that way, and also I'll show you the way to do it with the calculator and the computer. So what I did was I did 14, first one, 14,381.03 divided by 7,000. He gave me this. Then I did, now my lean is just here. So my lean is on the black button. So I don't need to press shift. I'll just press lean. Okay, I press lean, but that's the lean of the answer. Now my answer is on the red. I mean, is on the, will I call this orange? Yeah, it's on the orange. This is my answer here. My answer is on the orange button above the minus sign with the parenthesis. So I have to press shift. I press shift, and then I press it. So this gives me lean of the answer. That's this lean of this answer equal to this. Okay, equal to that. Then the next thing I do is I press divide that by 9. Because if I press divide immediately, answer comes up. So I don't need to. That's the way this calculator works. So this is what I got. Then times 100, 7.9999, which is 8%. Okay. Now, that is with this calculator anyway, with my calculator here. This is one of my numerous calculators. But I like it because I like this calculator. I've used it actually for more than 4 years now. Casio FX 9750G Plus. Casio didn't tell me to advertise for them. I've used it for more than 4 years without problems. And it uses rechargeable batteries. I use rechargeable for, that should be AA or AAA. That should be AAA batteries. Yeah, 4 AAA batteries. Yeah. It has served me for more than 4 years now. Now I have other calculators as well, okay? But this one is nice. Yeah, it's nice for what I'm using it for right now. Now, as business students, you probably might want to get financial calculators. I don't know whether you have it if you're a business student, but if you're doing only finite math just for this, then any calculator will serve. Even the calculator on the computer will serve. Okay, so in this case, 381, it's good to always remove your memory, the memory on the calculator, anytime you're not using it again. Not your memory, but the memory on the calculator. My bad. Divided by 7,000. 7,000 is this. Then you now do the lean. Go ahead and press lean, because with this calculator you press the number before you press lean. So when you press lean, it gives you that, and then you now do divided by 9. Divided by 9. Press equal to, it gives you that, and then you multiply by 100. Yeah. So, all right, folks, you got it right. All right, I think that's the thing that will kind of take us time, which I've done. The rest won't really take us time. All righty. Number 4. Now we're going to find T. A is equal to PERT, the same way PERT equal to A. So ERT will be A over P, then take the natural logarithm of both sides, Ln ERT is equal to ln A over P. Then RT will be ln A over P. So T will be ln A over P divided by R. Just like we did for R. We do the same thing for T. So let's get our T. How many years? T will be ln A is 14,381.03 divided by, I'm doing number 4. Let me erase this. Okay. A is equal to 91,000 divided by 74,654 all over R. 9.9% is what? 0.099. 0.099. So T will be, with your calculator, you do the same thing here. 91,000 divided by 74,654. Then ln of my answer is this, then divided by 0.099. So you get 1.99, 1.999953541 years. They say run to 2 places of decimal as needed. Now look, if you run this to 2 places of decimal, it's going to give you 2. Okay? This will give you 2 years. I mean, if you run it, automatically gives you 2. Okay? Now, some textbooks might write 2.00. So, just know what your instructor wants, okay? Alright. Number 5 and 6, and then we are done. Okay. You now have a lot of space. You now have enough space. Number 5. How long will it take money to double if it is invested at 9% interest rate, compounded continuously? In this question, they did not give us, something is lacking, right? These are continuous compound interest formula, PERT. Now, something is lacking. They're asking us how long. T, asking us to find T. They didn't give us A. They didn't give us P. And they gave us R. So, 2 things are missing they didn't give us. I mean, well, 3 things are missing, but out of that 3 things, they told us to find one of them. They didn't give us the other 2. So, excuse me. So, how will you solve this? How are you going to solve this? How long will it take money to double? Do you know what money? No. Let the money, whatever you don't know in mathematics, what do? Assign a variable. So let's call the money P. What you don't know in math, assign a variable. That means what you don't know. P. So how long will it take P dollars to double? So the amount in this case, so the money is P, and that is also the principal. Okay? Now the amount in this case, you need that principal to double. So it will be 2P. It's going to be 2P because you want it to double. Okay? So we have, and they're asking us for T. Now what did we get as our T? Our T was ln A over P divided by R. Okay? Now what was our R? R is 9%, which is 0.09. So now this is T will be ln A is what? 2P over P. Are you with me now? Because your A is 2P. Amount A is 2P. 2P over P. Then divided by what? 0.09. So this implies that your T will be ln 2 over 0.09. This implies that your T will be, because 2p divided by p, then p will cancel p. That's why you have 2. So you do ln 2 divided by this, ln 2 divided by 0.09. With my calculator, I just put it like that, ln 2, just like that, divided by 0.09. So that will give us, in this case, they didn't tell us to round, right? Assuming they tell us to round to the nearest, to 1 decimal place, or to the nearest tenth. To the nearest tenth means 1 decimal place. That will give us 7.7 years. I don't know whether it's what you got. Let's check it. Okay. Let me do it again. Ln 2 divided by 0.09. Yeah, 7.7 years. That's what I got. So it will take 7.7 years for the money to double. Wow, that's a long time. Well, before you know it, it's not so long. Okay, the last one, number 6. The last one, number 6. If the population of a certain city is growing at 1.2% compounded continuously, how long will it take the population to double? Round to the nearest integer. Round to the nearest integer. So this is very much used in statistics, in your population growth. Okay? Analysts use it to predict population growth. Like when you hear, okay, the world's population will double at so time, or will be so time. It's this kind of formulas that they use. Okay, for businesses, for economics. Economics predicts what something will be. Predicts, probably have some errors, but not much significant errors. So you can predict population growth. So that will be what now? What we got? So T is equal to ln A over P all over R, right? So this gives us that T will be ln A. We want the population to double. So let the population be P. Let the population be P, and that is the principle. Okay? Number 6 is similar to question 5. Okay? So the amount you want later on, you want the population to double, 2p. So this is 2p over p all over r is 1.2%, which is 0.012. Okay? So your t will be what? Ln 2 over 0.012, which gives us what? Ln 2 divided by 0.012. And there's 57.8 years. But they say we should round to the nearest integer, so t will be 58 years. 58 years. Make sure you put the years, okay? It's very important. That's the unit. Alright. If you have any question, please feel free to ask me. If you're my student, please use the school email. If you're not my student, you can ask it on the YouTube channel, or you can go to contact me. You can just contact me at www.samuelchukwuemeka.com. There's a contact form there. You fill it. Thank you so much for listening, students, and you have a great day.